Hello, in this video we are going to try to find the determinant of a 4x4 matrix. So the purpose of this video is to look at, what it looks like to find the determinant of a bigger matrix. So in order to find a determinant, we have this little formula that says A11 times C11 plus A12 times C12 plus A13, and it goes on and on, plus all the way until A1n, C1n. And what does that mean? Well, this A is talking about one of the matrix terms, and the C is talking about the corresponding cofactor. Okay, and a cofactor is then broken down into -1 to the I plus j times mij. So that's broken down to -1 to some power times the minor. And the minor is just the determinant of the matrix that's left over when you delete the I and j rows of that minor. Okay, wow, that's a lot to break down. And it makes sense when you look through the example. You just add all these components together. The neat thing is you can apply this formula for a determinant to any row or column you want. So usually you try to choose wisely of which row or column you choose. Because you are multiplying each of these cofactors by the term in the matrix, if you multiply by 0, well, you don't even have to find that cofactor because 0 times anything is 0. And for that reason, you always want to look at the matrix you're trying to find and choose the row or column with the most zeros. Just makes your life easier. So when I look at this matrix, I'm going to choose this column right here. And we're going to do our cofactor expansion on that column. And again, that formula for the determinant seems pretty complicated. But I think once we work through the problem, you will see it's not as complicated as it seems. So our determinant is going to equal, we take our first term, and then it's going to be times its corresponding cofactor. So we're going to slowly break this down piece by piece. So 6 times, that would be cofactor. I'm in row 1, column 3, so 1, 3. And then it's going to be plus 3 times the cofactor of second row, third column. And then I'll just write these even though we don't really need them, but plus 0 times the cofactor 3, 3, plus 0 times the cofactor of row 4, column 3. Now those are both going to go to 0, so they don't really matter, but I wrote them there anyways. Okay, so cofactor 1, 3. What is that? Well, that is -1 to the I plus j, so you add 1 plus 3, times the minor of 1, 3, which is equal to 1, because that's -1 to the 4th power, times minor 1, 3. Now, as I go to the next one, I want to do this part real quick before we find the minor. What about cofactor 2, 3? That's -1 to the 2 plus 3 power times the minor 2, 3, which that time it's -1 times minor 2, 3. So what does that look like in our formula? It's 6 times 1 m13 plus 3 times -1 m23, which creates 6 times the minor of 1, 3 minus 3 times the minor of 2, 3. Notice how we rotated between a positive and a negative, and then this one would be positive and that negative if we had it. So that -1 part of the cofactor, it's on a rotating pattern. It switches between positive and negative. And in fact, if you look at the whole matrix, it creates this checkerboard pattern of positive, negative, positive, negative, positive, negative, positive, negative, positive, okay, and so on. In fact, maybe I'll even write that over here, positive, negative. It's always doing this checkerboard pattern of positive and minus. So as you're determining if your cofactor should be a positive or negative, like should you switch the sign of your term or not, you can think about where it is on the checkerboard pattern. Or you can think about if the term is 2, 3, well, those add up to an odd number. 2 plus 3 is 5. So therefore it's negative. because the power of the cofactor would be negative, would be odd. So all that is to say, in my thought process, as I'm looking at this step here, I'm thinking, should I switch the sign of 6 or not? So I say 1 plus 3 is 4, so that's even. So 6 is going to stay the same sign. Then I go to the next one, and I look, well, I'm on the term 2, 3, so 2 plus 3 is 5. That's odd, so therefore the sign of this is going to change, and therefore it's negative 3. And my next one would be positive, and my next negative, because I know the cofactor flips. All right, so there we're dealing with that plus or minus idea of the cofactor. Now, what is the minor? The minor is when you take the term you're at, so for the first one, I'm at 6, and you delete the row and column, and you find the determinant of what remains. So this becomes 6 times the determinant of the matrix 2, 7, 6, 1, 5, 1, 3, 7, 7, minus 3 times, so now I go to that one, 3, and I delete its row and its column, giving me the matrix 2, 6, 2, 1, 5, 1, 3, 7, 7. And now you see how a 4x4 can be a lengthy thing, because I now have to define the determinant of 2 different 3x3 matrices. And to do that, I have to do another cofactor expansion. Let's try that off to the side. So first, I'll do this, we'll call this matrix B, and this matrix C. So to find the determinant of matrix B, that's going to equal, well, what row should we use? This one doesn't have any zeros, unfortunately, so maybe we'll just try our first column right here. So this determinant is going to be 2 times the cofactor of 1, 1, plus 1 times the cofactor of 1, 2, plus 3 times the cofactor of 1, 3. Now, do I switch any signs? Well, the first one is going to stay positive, so it's 2 times the minor 1, 1, plus or minus, because this one switches now, minor 1, 2, and then this next one stays the same, so 3 times the minor 1, 2. Now, when I do the second determinant of C, I'll go a little quicker with it. But I'm still kind of going slow with these. Now, when I do minor 1, 1, so we're at the term 2, so I cross out that row and column, telling me I need to find the determinant of the 5, 1, 7, 7 determinant. And luckily that's a 2x2 matrix, so that determinant is sort of easy to find. Now minor 1, 2, so I go to the term 1. Sorry about that. Let me put back in what I erased. So that was 2, 6. All right, so I go to my 1, 2 determinant, and I cross that out, leaving me the matrix 6, 6, 7, 7, plus 3 times minor 1, 3, it should say. So now I go to term 3 that we're at, and I cross out its row and column, leaving me the matrix 6, 6, 5, 1. And I have to find the determinant of that. All right, now with determinant of a 2x2, it is just 5 times 7 minus 1 times 7. Or you can call that A times D minus B times C. So we are going to get 35 minus 7 minus negative 1 times 42 minus 42 plus 3 times 6 minus 30, giving us 2 times 28 minus, well, 0 because I have negative 1 times 0, plus 3 times negative 24. Continue on, 2 times 28 is 56, minus 3 times 24, 72. So then I have 56 minus 72 is equal to negative 16. So I just found the determinant of B is equal to negative 16. So going back to my original formula, which is finding the determinant of A, I now have 6 times negative 16 minus 3 times, well, now I have to find the determinant of C. So we'll slide down. And this time I'll try and go quicker to kind of show you how it doesn't have to take that long to find the determinant. So what do we want to do for C? This time let's use a row. I'll choose 151, the second row, just because it has some ones, so maybe that will make it a little bit easier. All right, so we're gonna go 1, but should I change the sign? Well, it's positive, negative. Yep, so this is gonna be -1 times the determinant of the leftover matrix. So 6, 2, 7, 7. Okay, and then from there, it's now 5. So it's plus 5, and I keep it at positive because we're going positive. So it's negative, positive, negative. Cross out, and I have the matrix 2, 2, 3, 7. Okay, and lastly, I go over to 1, and this time it's going to be -1. And what matrix is left? If I cross out the row and column, I get the 2, 6, 3, 7 matrix. 2, 6, 3, 7. To find those determinants, -1 times 42 minus 14, plus 5 times 14 minus 6, minus 1 times 14 minus 18. Okay, so -1 times 42 minus 14 is 28. 5 times 8, and -1 times -4. -28 plus 40 plus 4 gives us 16. So that's the determinant of C. So now we go back to our formula right here. The determinant of C is 16. So we're left with 6 times -16, which is -96, minus 48. And 96 minus 48 is -144. Let's slide up so we see the whole work of our determinant. Okay, so you first take your determinant A, you choose some row and column, that's how we got these numbers. And then you find its cofactor, which breaks down into a minor, and a minor is just deleting each row and column and finding the resulting determinant. And then if that determinant is still a 3 by 3 or something bigger than a 2 by 2, you have to break that down. And so we broke that down by taking it over here and finding each individual determinant until we were able to go back to our main formula. So if you stay organized, it's not so bad. It can be lengthy for sure. You have to keep breaking your determinants down until it's a 2 by 2. Once you get a 2 by 2, you can easily find the determinant. But here we go. -144 is the answer for our matrix.